So today we are going to cover integrated rate equation, that is for zero order reaction. Okay, so first we will consider that is there is a reaction called R2P. Okay, and a reaction is going on from reactant to product side. So if the reaction belongs to zero order reaction, so we will be writing our rate will be written is equal to K concentration of R raised to the power 0. Okay, like this. Similarly, based on this concept, since everybody knows about that, the rate for integrated integration, we will be writing by d concentration of R divided by dt. So rate will be written like this, which is equal to K, and concentration of R raised to the power 0 will become 1 here. Next we will be writing, for example, if the value is having minus d raised to d concentration of R divided by dt. So now let me write correctly, like d concentration of R minus, which is equal to K and dt here, like this. Now we have to integrate the equation. Okay, so on integration both side, so write down the integration. So on integration both side, you will get the value both side, that is integration of minus d concentration of R, which is equal to K is our constant, so we will keep K outside the integration, and dt here, like this. So here we are going to use some basic formula of the integration. So which formula you are going to use here? That is the integration of any, for example, if you are going to find out the integration value for dx, so integration of dx is written equal to x, simple formula. So similarly, by following this formula, we will be writing the values here, like that is concentration, here it will become that is minus concentration of R, which is equal to K, and concentration of dt integration will be written as t. After solving the integration part, we will be writing a integral constant, for example I here. You can write down C also. Sometime in few books it has written over the integral constant as a C. So I is here, for example, integral constant. After doing the integration of the first equation, we will be writing this equation, means first we will be finding out the value of I. So how do we find the value of I, that is at time 0 second. So for example, if the time is 0 second, so just put the value of time here in the previous equation. We will be having that is concentration of R, which will become equal to K multiplied by 0 plus I. So value of I will be written as that is minus concentration of R. Okay, since the concentration of R has found at 0 seconds, so here I am writing that is R node. But remember, this R node is your actually initial concentration, means when the time was 0, so we can say that our concentration was initial concentration of the reaction. Clear? I hope up to here everyone got the clearance. Okay, so this is my value of I. What am I going to do now? There was one more equation previously. Okay, this equation was also there. Now I am going to put the value of I into this equation. So what we will be having expression here. So this expression will become, which is equal to minus concentration of R, which is equal to KT, and minus the value of I is given as here minus concentration of R naught. Okay, I am just going to multiply by the negative sign from left hand side and as well as right hand side. So it will become R is equal to minus KT and your plus concentration of R naught. Clear? So this is an expression for the value for zero order reaction, which is very important for examination. Similarly, if you want to move, if you want to prepare the graph based on the same concept, we can also draw the graph on the equation. So it is written as, for example, if you compare with the equation of graph, which is equal to y is equal to mx plus c. So x is your t, okay, time, y is your concentration of R, and c will be our concentration of R naught. Okay, so clearly based on this one, if I draw one graph here, so I am drawing the graph here. So we will say that there is a concentration on y-axis of R, and it is our t, time. Okay, since you can see that the slope m is minus k, so directly our equation will show this kind of graph, like the negative sign, and it will touch the x-axis. Please remember this line, it will touch the x-axis. Why am I saying this one? Because we will cover it later on. So this point is your intercept area, which is called your R node, or you can say C also there, and the slope of the graph will be your M, which is equal to minus K. So I hope up to here everyone got it clear. Okay, thank you.